Hello, everyone. Welcome. This is Dirk from Made for Math. And today we're going to be talking about cats. Yes, you did hear correctly, cats. See, I have a friend who has a couple of cats, and just the other day she was telling me about how hard it is to feed them. Each of them has to have their food in a specific place. It can't be too far, but it also can't be too close. I thought that seemed like a lot of work, but she says it was worth it. So I thought that maybe we could use this strange cat behavior to talk a little bit about math. Before we do so, I'd like to just mention one or two brief notation things. So the first is about inequality signs. So first we have less than, and then less than or equal to, greater than, and greater than equal to. And the second thing is how we write these on a graph. So hopefully you remember that a less than sign has a hollow circle on a graph. Less than or equal to has a filled in circle on a graph. Greater than also has a hollow circle, and greater than or equal to has a filled in circle on our graph. And again, if we have equal to, then we're going to have this filled in sign. If we don't have that equal to part of our inequality, we'll have a hollow point on our graph. So first off, I would like to kind of show you the layout of where these cats eat. They all eat in the same kitchen, and there's a counter right in the middle of the kitchen. So Arthur's food, he's the gray cat, Arthur's food must be greater than or equal to 4 feet from the counter. So we're going to show this with this little purple dot and say that Arthur's food has to be more than 4 feet from the right of the counter. Okay, and if we add a little bit of a line there, that's what it's going to look like. And we can write this as Arthur's food is greater than or equal to 4. Now, if we write that as a inequality and we replace Arthur's food with an X, let's draw that in blue here. We're going to have that Arthur's food, or X, is greater than or equal to 4. And if we draw that on our number line, we're going to have X is greater than or equal to 4. So with an arrow getting bigger than 4. And again, we have that filled in circle to begin with. Merlin, on the other hand, only eats food that is more than 3 feet to the left of the counter. So if we're going to draw this on our number line here, we're going to have to do it to the left of the counter. So that means that we're going to put our food 1, 2, 3 places to the left of the counter. Right there. Well, we also know that it has to be more than 3 feet to the left of the counter. So our line is going to be pointing this direction. We've got an arrow there saying that, hey, anywhere to the more than 3 feet to the left of the counter can be where Merlin's food is. But it has to be more than 3 feet. We can't have it exactly 3 feet. So we would write this as an inequality as Merlin is is less than, more or less than, I think I've been saying 4 and I need to be saying 3, sorry. Merlin is less than 3 feet away. And because we don't have that equal sign in our inequality, when we come to graph this on our number line, if we switch colors here, we're going to use a hollow circle. So we'll put that hollow circle right there. And then our line will extend. Should be a straight line like that, out for forever there. So anywhere to the, or anywhere that's less than 3. And if we consider that our counter is at place 0, then the way that we would write this inequality is x is less than -3. And that's what this green line here represents on our number line, is where x is less than -3. Lance, our third cat, will eat any food that is between 3 feet and 4 feet of the counter. So let's draw where this might show up on our graph. So if we go 3 feet to the left of the counter, that would put us right there. And then 4 feet to the right of the counter, we'd go 1, 2, 3, 4. We'd put our line right there. And if we connect those two dots, though that right there represents the part of the kitchen where Lance will eat any of his food. So how then do we write this as an inequality and graph it exactly? Well, if we take a look at this, if we have here, this is 0, oops, this is 0. That puts us at -3 here and +4 here. And our food can be exactly 3 feet from the counter, and it can be exactly 4 feet from the counter. Just has to be somewhere in between there. So if we write this, we would say that x has to be greater than or equal to -3, but it also has to be less than or equal to +4. And the way that we write this, kind of in a more simplified way, is that this right here is exactly the same thing as -3 is less than or equal to x, which is less than or equal to 4. And if we go ahead and draw that inequality on our number line, we're going to put a closed circle at -3 and a closed circle at +4. And then we'll connect those two dots just like that. And that's how we graph the inequality. -3 is less than or equal to x, which is less than or equal to 4. Now, if we go back to our cat example, well, that's a little bit complicated to figure out where exactly we can put all of the food for our cats. But if you just think about it, that, well, Merlin has to be more than 3 feet to the left of the counter, or x has to be less than -3. And for Arthur, we have to be greater than or equal to 4 feet from the right of the counter, meaning that x has to be greater than or equal to 4. And Lance has to be somewhere in between those two. It makes it a little bit easier. Now, feeding that many cats is still a little bit complicated, but hopefully graphing inequalities isn't quite that complicated. Thanks for joining us, and we'll see you next time.